The ball was now in the court of the steel fabrication plants. The track had to be made to the exact specifications of the computer models to keep the G-forces true to the design.
Some manufacturers are able to follow our calculations with coordinates, and they do fabricate very, very precisely up to tolerances of 1/10 of a millimeter.
One manufacturer brings Stengel's esoteric equations to life better than any other. With rides as smooth as butter, Bollinger and Mabilliard are known as the Mercedes-Benz of steel coasters. At their fabrication plant outside Cincinnati, Ohio, their steel monster machines take shape. Visitors here are rare. In the dog-eat-dog coaster wars, the secret processes behind B&M's creations are closely guarded. Inside this exclusion zone, filming is strictly controlled. Every element of the process, precision cutting, track bending, and welding, adhere to Werner Stengel's hardline principle. It begins with some serious firepower. The design coordinates are set into their cutting machines. The computer does the rest. The oxy-fuel cutting machine carves out the steel joints that will hold the track in place, slicing through the thick steel sheets with a jet of pure oxygen-enriched flame. For more delicate work, the raw steel is loaded into the shallow tank of the plasma burner and flooded with water. The plasma torch cuts up thinner steel pieces like the box supports with an electrically charged or ionized gas that creates an intensely hot, concentrated flame. The torch slices up the steel underwater, cooling the metal to eliminate distortions. The seam has to be perfect when the welders join the pieces together. The massive sections are shifted into the welding stage, where much of the work is still done by hand. First, the box supports and joints are assembled and welded into place. Each seam is carefully checked. The obsession over quality control includes ultrasound testing that measures the thickness of the welds and reveals any hairline cracks. Then, the defining moment. The rails of track are inched into place. The supports must conform perfectly to the curvature of the rails. If they are off by even a millimeter, the rail cannot be forced to fit the brace. Even small distortions of track geometry from the original computer design will be magnified, resulting in a rougher ride. Finally satisfied, the artisans begin welding the track into place. Once constructed, the track sections are left outside for weeks, letting nature take its course. As the rust accumulates, it attacks and loosens any tiny pieces of excess metal. The rust and impurities are blasted away, and the track section is ready for the final pass. A heavy spray of specialized zinc-based paint to withstand up to 10 years of Mother Nature's fury. It is these refinements in computer design and manufacturing that have created the most extreme roller coasters of today. But have we reached an impasse, or will new advancements allow engineers to push the thrills to yet another level and keep the forces on the riders in check?